yeah, we're happy to be giving this talk. It's going to come from about 6 projects that we've used asset bundles in over the past year and a half. So before we get too much in depth, I wanted to get some sense from everybody how familiar everybody is with asset bundles. We're going to be jumping mostly in all the way right away. But we want to know how much basic stuff to go over before we get into that. Could I get a sense from everybody, like a show of hands, who's built an asset bundle in Unity before? Awesome. OK, cool. And could I get a show of hands who has built or used an asset bundle pipeline in Unity before? Hey, right on. Sweet. And one last show of hands, who's run into amazing secret asset bundle bugs in Unity before? All right, cool. So these are mostly fixed. We'll mention them in passing. But yeah, this is good to get started.
OK, so we should just go over a quick refresher what asset bundles are, why they're useful, why you'd use them instead of some competing solutions. So asset bundles are dynamically loaded, runtime-ready assets. That means that they're assets that have already gone through Unity's importing phase. They're ready for use in the engine. They're ready to load quickly. They're much better than, for instance, trying to read in a data file and text and build it into a mesh at runtime. It's probably already in a blob that looks like a mesh in Unity once it's an asset bundle. So unlike resources.load, an asset bundle doesn't need to be known at build time. That means that when your application is running, you could download a list of existing asset bundles, for instance, and then load them in at runtime without having known about those asset bundles before you built your program. And that's the main difference between that and resources.load, besides the fact that the asset bundle is also separate from your project binary. They're Unity Pro only. So how do you create an asset bundle? Well, right now, you do it with editor scripting. Specifically, the functions you're looking at are buildPipeline.build asset bundle or buildPipeline.build streamed scene asset bundle, which is just an asset bundle that contains a scene, since scenes are assets, but they're not exactly assets in Unity. They can be compressed or uncompressed, and it's really important to kind of respect the asset bundle as kind of a full pipeline feature in itself instead of just sort of trying to load them willy-nilly with path strings. You're going to generally run into a pretty bad situation further on in your code. You have to keep good track of the lifetime and such things for asset bundles in order to use them well. So here's an example of making one. This is taken straight from the Unity docs. It's getting the selection in the project folder. It's building an asset bundle with the active object being the main asset in the asset bundle, and it's collecting the dependencies and creating the path that you choose in the save file panel there.
So in order to use an asset bundle, first you need to get the bundle into memory. And you can do that with www.load from cache or download, which takes a URI. And if it's already got an up-to-date version, then it just gets it from the disk. Otherwise, it'll go to whatever remote location you specify, download it, and then get it from there. Or you can also load it from disk directly, which is quite fast. Then once you've got the bundle in memory, you can pull the assets out of it with load to get a single object, load async, which does the same thing but asynchronously with the coroutine system, and load all, which gets you an array of all the objects that are in the bundle. And what you would use asset bundles for in typical cases are if you had a web player, you would want to keep the size of the actual player small, and you can do that with asset bundles by hosting a lot of your content on your own server somewhere. and send it out to players only as they need the content. And another use for it is you can store your content on a server and update it frequently so that you don't have to patch somebody's game client on their phone or whatever device.
So, as I mentioned when we started, there definitely were more than its fair share of bugs in asset bundles. We bumped into a bunch of them. There were some mysterious C++ console errors. There were memory leaks when you were loading and unloading content in different ways. And there was a wonderful bug where unload false would destroy assets that were being used, often instantiated. We've run these through basically our kind of backlog of projects. We've brought them into 3.5. We've basically put them through their paces. And the bugs that we had been seeing over the past year and a half are taken care of at this point. We've also spoken to the Unity Technologies guys. They're pretty confident in the state of asset bundles at this point. So they're definitely a thing to use with confidence now, and start to tear away our traditions of having a dance before you load and unload them to get them to work properly. I think at this point we can use them as they were intended. So yeah, as Harrison mentioned, there's two primary ways that asset bundles are loaded, and both of these are relatively new. If you have a compressed asset bundle, which seems to be the case most of the time, you definitely want to use load from cache or download. The traditional way of www and getting a direct reference to the asset bundle, this is less efficient. You end up having the full asset downloaded and then buffered. You definitely want to use this. It pushes it directly into memory. If you happen to have an uncompressed asset bundle, which is advantageous actually a surprising amount of the time, asset bundle.create from file is fast, and it's a blocking operation, so you can do it at the beginning of a scene, for instance, without having to have a loading bar in between. And it's really fast. It's comparable to scene loading assets. Yeah, so both of these are the two preferable functions. They provide better memory usage, particularly at loading time, which is important, as we'll talk about in a bit.
So I'm going to talk a little bit about asset bundle memory management. So asset bundle unload is critical function to know about and use properly. It must be called on every asset bundle you load. If you don't store a reference to your asset bundle, there's no way to reclaim that memory, not with a scene load, not with an unload unused assets call. There's just simply no way to get that memory back. It's going to be gone, and your application's going to have higher memory usage after that. So the there's one flag that you can pass into unload, and that's the true or false for unload everything, essentially. So unload true, what it does is it destroys all the instances that you have that reference assets that were in that asset bundle, and it also destroys the memory that is the asset bundle itself. So when you load up an asset bundle from the disk or from the web, you've got this copy of data which your assets are loaded out of. That data itself is destroyed in both unload true and unload false. So the difference with unload false is that it leaves all the references behind that you have into assets that were in the asset bundle. So for instance, you have a reference to a texture or a model that you loaded out of the bundle. It'll keep those references around, and you have to clean them up manually, either by destroying all the objects that reference those assets and then calling unload unused assets, or by changing scenes. An interesting thing here, a lot of people are still loading asset bundles with www and the .asset bundle property of that. You need to release the www object, as I'm sure most of you know from loading anything over the www interface. And you can do that by calling .dispose. So most of your mobile memory crashes are going to be from peak memory use while loading scenes or loading objects dynamically in the middle of scenes. There's a few things you can do to mitigate those problems, especially when you're using asset bundles. So going back to destroying this www object, after you pull the asset bundle out of the www object, but before you actually load any assets out of it, you can destroy the www object, and then your total memory cap will be lower than if you destroyed it after you've already accessed all the assets out of the bundle. Another thing you need to be concerned with is the size of your asset bundles. Because you've got a kind of duplication of data in memory when you're loading from asset bundles, the bigger the bundle, the more you're pushing up your cap kind of in a way that doesn't need to happen. So if you have one 50 megabyte asset bundle that you're loading 10 things out of, it's probably better to have 10 asset bundles that you're loading 5 megabyte things out of. Your total memory cap only needs to be 10 if you do it in sequence versus 100 if you did it the other way.
So there's a fun issue with build stripping, where if you turn stripping on in your build, it will strip out components that are not used in the build. And with asset bundles, those aren't considered part of the main build. It has no way of knowing what you're going to use. So sometimes you'll make a build, you'll make an asset bundle, and if the asset bundle uses a component that's not in the main build, then your game will try to access it, and your game crashes. So there's a couple ways around that. There's a no-strip XML file, which you can put all of the component classes in, and that tells Unity not to strip them out. Or you can have an object in a scene in the main build that uses all the components that you want to use. Or if the size of your build isn't that important, you can not use stripping.
And this includes all components, like things such as mesh renderer. If your project doesn't have a mesh renderer and you have a mesh in an asset bundle, and you have full stripping on a mobile device, you're going to have runtime errors. So
an issue with asset bundles is that they're problematic for like the workflow that you use. You have to build them with your tools, and that can take a while. You also will have code that builds these things that you have to maintain, and it's just a bit of overhead on the entire process, so you have to be careful. There is a solution so that you can avoid building asset bundles while you're testing in the editor. A way to do that is you have a class that wraps getting asset bundles. So instead of pointing it directly at a URI or a place on your disk, you can abstract that away and make it so that in the editor, it uses an alternate method to get the resources instead of getting them from an asset bundle. So you can use the resources folder for that, although you want to make sure that you don't include the resources in any actual builds. Or you can use conditional compilation to use the asset database.
So yeah, as Harrison was saying, a proper pipeline becomes really important when you're using asset bundles. Ideally, you never want to be manually, pressing build bundle. When you have asset bundles that are included in deployment builds, you're definitely going to want to have a build tool that automates the building, moving, incorporation, the whole 9 yards for including those bundles in the final product. And as you start to do that, you start to spend a lot of time watching Unity build asset bundles, and it starts to become worthwhile to keep track of which ones are dirty and which ones aren't dirty. And you can do this pretty straightforwardly by monitoring which assets have been targeted for an asset bundle, monitoring when they've been changed, when there's been a dirty or a timestamp change on them, and then marking that asset bundle that holds that asset as needing to be rebuilt.
Yeah, there's one gotcha there, actually. With the metadata files that are in Unity, before there was the .meta files, there wasn't any good way to see if the metadata about an asset had changed. It wasn't very easy to look that up. Now, if you're using the .meta file type Unity project, then you can check the meta files for their modified date as well. And that's a much better way of checking if assets are out of date. Sometimes before, you would have to rebuild all your asset bundles anyway because you didn't know if the metadata had changed.
Another thing that's kind of interesting is that when you're building asset bundles, particularly bundles that are wrapping work that an art team is doing, for instance, it's a really good opportunity to do validation on your content. Often, in fact, almost always, the asset bundles are wrapping game data, not logic. So you can do things like, to begin with, check to see if all the fields in an asset bundle are filled out. And if they're not, throw an error when you're building asset bundles. It's going to save you a lot of time. It's much better to fail at build than at runtime. You can start to do more interesting things too. You can provide warnings when your vertex count is getting high. Something to tell the artist when they try to build the bundle, hey, lower your vertex count. You can even go so far as to include information about level data, pathfinding, spawn points like this. See if an asset has been properly set up before being put into an asset bundle. Since you're building a pipeline around this asset bundling process, this is a good opportunity for validation. And then, finally, as I mentioned to begin with, you definitely want a build tool that, particularly if you're targeting multi-platforms that have different asset bundles for each platform, you're going to want that tool to do the work for you. You never want to be finding yourself typing in an asset bundle path. You never want to be finding yourself dragging an asset bundle around. If you do that, you're going to cause mistakes. Take the time, build a pipeline that has a proper build tool, or use one of them that is available. There's actually quite a few nice ones in existence. So before we get into creative uses, I've got a little bit of information here about compressed and uncompressed asset bundles, their size and their performance. So as I'm sure people are aware, compressed asset bundles are LZMA compressed, and it's compression over the entire binary blob of the assets plus the index. It's worth noting that this is different from per pixel compression. Your choice of formats for your textures has a constant sort of compression effect on the final result of the texture. The LZMA compression is variable. It's pretty good, though. Compressed asset bundles use about a third of the size on average from uncompressed asset bundles. This includes mixed assets, an asset bundle that contains meshes, textures, game objects, scripts. So it's a pretty, if you're looking for binary size savings, it's a great way to shrink your content. Uncompressed asset bundles are roughly the same size if you had the assets in a scene. So if you put something in an uncompressed asset bundle, you're not helping or hurting yourself too much in terms of size. In terms of loading, however, uncompressed asset bundles are similar in speed to scene loading, almost identical. Sometimes we've seen them be a little bit slower, but for the most part, they're basically the same as loading it from a scene. Compressed asset bundles, on the other hand, are like 4 times slower. It's pretty slow. So when you can, use uncompressed asset bundles. They're great. Compressed asset bundles really need to be reserved for cases when file size is a significant issue.
So I'm going to talk about a few ways that you can use asset bundles a little bit differently to try to solve sort of problems that you have building different types of projects. The first and maybe most obvious thing to do is to take your different build targets. That's all the platforms you're targeting. That might be iOS and iPad as 2 different targets, even though they build the same Unity build target, and make a different asset bundle for the same content for each one of those platforms. And by doing that, you can sort of kind of substitute the right assets in without changing any of the logic in your scripting or your GUIs, anything like that. You can kind of substitute one set of assets in for another one, almost opaquely, so that the code doesn't know the difference. Another really good thing to use asset bundles for is really large streamable scenes. So if you have, for instance, a city or a giant piece of terrain or one large thing that you want to be able to move around at a continuous speed and see the new things come into existence and see the old things be destroyed, you can use asset bundles to kind of partition your level up into different areas. You can build a grid logic system that kind of loads the pieces as you come close to them. and then unload them as they go out of view. It's really important to keep your mobile games on the data, mobile data download limits for the various stores that exist out there. There's additionally some stores for some devices on some platforms, Samsung, Android, that give you really stringent limits on what you can download onto the device. So what you need to do is keep your mobile game under a specific size. So say you've got a 200 megabyte game that's like a storybook that you go through. You might put up a binary that's only 20 megabytes. The user downloads that, and when he opens it up, it starts downloading the content in the background. You can use www.loadfromcache or download to do that very easily. It will not result in multiple downloads for no reason. If you have a game that runs off a server, or you have a persistent server in your world, if you want to update the content in the world based on, time passing or just general editorial type things, you can load that content from asset bundles. Like for instance, if it's a park, you can change the colors and the textures with the season, that sort of thing, and do that for your users as they're playing, kind of in the background without having to give them binary updates. So code updates, that's something that a lot of people want to do. Sometimes they don't want to enforce, they want to get the new code into their project without requiring somebody to say, hey, I want to update this. So a lot of people want to kind of push a new level that has slightly different logic than any of the previous levels they had, or they want to add a new experience to their game or application, yet they don't want a user to have to go to the iOS store and say, OK, I want to update this. Before, people have tried, and it's probably not a great idea, to take a .NET DLL and ship it over www and run code out of that after you load it into the runtime. That doesn't work with iOS, and it doesn't work with the web player, but you might be able to get some of that working with Android, and you might be able to get some of that working with standalones. I know that there was an experiment that Angry Ant did a few years back to make that work. But probably a better solution is to build your scenes and levels out of components. That is, pieces that interact well with each other and kind of do things in a fairly generic way so that you can build levels out of these small pieces without needing to create new ones for everything you do. A typical type of thing would be you'd have a collider that has a trigger on it. If you walk into the trigger, an animation will play. So if you build your levels that way, updating script via asset bundles is feasible.
It's 3 o'clock.
So another way you can do asset bundles is you can have a server running that makes asset bundles for you by some automated process. So as an example, you could have a user submit a model and a texture, and then that goes off to a server somewhere, which copies the assets into the right place, and then runs an instance of the Unity editor in headless mode, which can execute a script to build that into a proper asset and do all the post-processing. And then you can have other users download that asset bundle and use it. And you could do a similar thing if you wanted to have automated asset bundle building for your own internal purposes, like whenever you commit or something.
And that can be helpful, especially if you have a fairly large or external art team that needs to deliver content to Unity without all of them necessarily needing to know that you're using Unity even, or keeping that abstracted away. They can just submit the art assets to an uploader, and you can build your asset bundles and drop them down into your game without anyone needing to open the Unity editor. We also built this asset bundle tool to make it a little bit easier to use asset bundles for a fairly basic project. I'm just going to pop in here and show it to you now. So here's a typical project that has nothing in it. There's this little soldier. I believe he's a Mixamo-free soldier that you could download from the asset store. I'm just going to import the asset bundle helper project here. So once you import that, there's this little scriptable object for the settings where you can set up which platforms you're using. So I'm targeting iPhone, iPad, and Android as my different build platforms. And I associate a Unity build target with each one of those. So you can have overlap. So for instance, iPhone and iPad both target the iPhone build target, and it handles those things elegantly. So I go ahead and I create a new asset bundle listing here. And you can see the listing here on the right side of the screen. And in that, I can add a new asset to an asset bundle. I'm going to add the soldier. And I dropped him in the default slot, which means that any of the other platforms that don't have an asset for that entry will use that. Now let's say I'm adding a material, but I'm concerned about the texture size and which shader settings are set up. So I go ahead and I drag on the soldier's material, but for the iPhone and Android, I drag on a different lower quality material. And that's going to be accessed through the asset bundle using the same name as the default material, and it'll be done totally opaquely, and the engine doesn't need to know about the difference between the two. I can choose whether to gather dependencies or whether to compress the bundle, and I can press build to build it for the current platforms that I'm in. So you can see that I'm currently in iOS in my build settings. So it would build it for iPhone and iPad. I hit the button, yada, 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 and they appear in the build folder, which I can just show you here. There they are. Okay. Now that's all well and good, but the big problem is keeping track of which ones you need to rebuild. So we built this asset bundle manager. And this lets you know for each of your asset bundles, I only have one right now called listing, which ones are built and up to date. So this little checkbox indicates that that bundle is built and it's up to date. Now, you also need to know, when you need to rebuild them. You can see which ones aren't built, but you don't know which ones are out of date. So I'm just going to go ahead and click this material and go to it and change the main color a little bit for the iPhone version of this material. And the vertex lit shader is a little bit too shiny, so I'm going to turn down the specular color. Now if I refresh my view, I have to save, sorry. Let's save the project. OK, so now if I look at this view, I can see that the iPhone bundle is out of date, and I get an option to build those for the platforms that I'm currently targeting. And you can see it's back up to date. So this is available on twistedoakgames.com/blog right now for free. It'll be submitted to the asset store sometime next week. That's all we have for you today. We'll be taking questions for the next 5 minutes or so.
Yeah, no time for questions. Actually, I don't think we have time for questions, so thanks a lot, everybody. If you guys have any questions, feel free to track us down through the afternoon. We've got plenty of experience we'd love to share. Thanks, everybody.